Picture standing in a field at night. You see a flash on the horizon. Expecting a huge spotlight, you walk toward it. But it's just a pocket flashlight. Blazing so bright it makes searchlights look weak. That's the paradox astronomers faced when they spotted 3I Atlas. On paper, it's a frozen chunk of dust and ice from another star. In reality, it's lighting up in ways physics can't explain. So, what's really causing this impossible glow? Is nature playing tricks, or is there something out there trying to be noticed? Let's dive into the weirdest cosmic mystery of the year. How can something so small shine as brightly as something many times its size? That's the first riddle astronomers faced when they trained their instruments on 3I Atlas. At discovery, it looked ordinary, an icy body throwing off gas and dust, no different from the thousands of comets cataloged before. The spectra showed water signatures, the kind you expect when surface ice warms near the sun. For a moment, it seemed like the third interstellar comet was just a repeat performance. But the numbers didn't line up. If the light we see is sunlight bouncing off its surface, then 3I Atlas should be vast, far bigger than the two earlier visitors that passed through. Instead, the size estimates put it closer to something much smaller. The glow was simply too intense for the body that produced it. You can imagine the puzzle like this. Standing in a dark field, you spot a faint light. You expect it to be a big street lamp. But no, it turns out to be a pocket flashlight blazing far brighter than physics says it should. That's the oddity with 3I Atlas. Now here's where things get interesting. What if that glow is not a reflection at all? Some researchers suggest we consider the possibility that the object generates its own light. That sounds radical, but think of the energy math. To produce and sustain that output, you'd be talking about power comparable to running whole modern cities at once. That's a staggering demand for what should be a frozen fragment drifting between stars. No natural process we know explains this profile of brightness without an unreasonable jump in assumptions. Evaporation of ice, dust particles catching light, these models keep coming up short when checked against observations. This gap is why a handful of voices in the field ask if the glow is intentional. Could this be an engineered beacon rather than a wandering ball of frozen rock? Most astronomers stay cautious. They point out that comet activity is complicated, and jets of vapor and dust can amplify brightness in ways we still don't fully measure. To them, this is a comet behaving at the edges of known models, not proof of something built. That's a fair counterpoint, and it keeps the debate open. Still, the glow does not fade from the mystery. Whether natural trick or something stranger, it demands attention. And just when scientists try to settle on an unusual comet, the orbit throws a new curve. How could a random visitor from interstellar space follow a path lining up almost too neatly with our own planets? Imagine tossing a pebble from another star, and by sheer chance, it glides past Mars, Earth, and then Jupiter. That's the puzzle staring back at astronomers who track the orbital path of 3I Atlas. It's not just moving through the solar system. It's doing it in a retrograde sweep tilted so close to the main planetary plane that the path looks deliberate. On paper, it should be random. In practice, it feels arranged. The orbit cuts against the grain of most bodies we see from our own system. Instead of circling in the same general direction, 3I Atlas moves the other way, yet still intersects the very track that our planets share. The odds of that happening by chance shrink to an almost laughably tiny fraction. To picture it, think of buying a single lottery ticket that not only wins once but hits 3 jackpots in a row. That's the level of alignment scientists find themselves calculating. This is where the debate sharpens. If the trajectory is pure luck, then we accept it as one extremely strange roll of cosmic dice. But if luck seems stretched too far, then another avenue opens. Could the path be intentional? Space probes we design often aim for planets not because of coincidence, but because of the way gravity bends their routes. Gravity assists are free boosts or brakes depending on how you use a planet's pull. If 3I Atlas is nudging close to Earth or Jupiter, skeptics argue it might be exploiting the same trick. Here's where the tension grows. Our spacecraft swing by planets to gain speed. But a different maneuver exists, one that flips the purpose. A reverse solar assist, sometimes called a reverse Oberth effect, uses the sun's well of gravity not to speed up, but to bleed off momentum. In theory, something could dive close, shed velocity, and disguise its entry as the meandering curve of a comet. That is why some look at its orbit with raised eyebrows. None of this proves intent. Astronomers remind us that rare alignments can happen. The universe has room for coincidences, even improbable ones. But when rarity stacks on top of rarity, the brightness, the improbable trajectory, the point arrives where ordinary explanations strain. That's what makes technology a topic here. Even if the natural answer eventually holds, the shape of the orbit is enough to keep the question alive. And yet, another layer complicates the thought. Because if this were technology hiding in motion, it's wearing a disguise that looks an awful lot like a comet. So why choose that particular camouflage? If you wanted to hide in plain sight, space gives you endless disguises. That's the heart of the question with 3i Atlas. Why would something that might be artificial choose to look like a comet instead of showing itself as metal or machinery? The choice seems odd until you notice what comets already provide: an easy cover story. Telescopes show the familiar fingerprints of ice, silicates, and carbonates. These are the same ingredients astronomers expect when a cold remnant is heated by the sun. To anyone scanning the skies, the signature says comet at first glance. Nothing about that screams wrong or suspicious. Yet when you remember the brightness puzzle, a picture starts to build. Normal outgassing explains some of the shine, not all of it. Something else is happening with the light, and that mismatch is why the disguise idea even enters the conversation. The dilemma is straightforward. If 3i Atlas is ordinary, the glow should bank on sunlight bouncing off dust. But if the brightness exceeds that explanation, then you're forced to think in other directions. Here's an everyday comparison. Soldiers in the field wear camouflage patterns, not because the designs are perfect, but because they let you blend into the messy backdrop where nothing stands out. A similar logic could apply here. Space is filled with icy rocks trailing vapor. If you wanted to move quietly, wrapping yourself in the look of a comet hides you among countless others. No fanfare, no instant red flags. Now imagine the tactic in action. A disguised probe sails into a solar system. It carries a dusty shroud that observers chalk up as just another frozen visitor. Unless the light curve or trajectory tips you off, the object remains buried in the long list of comet candidates. Only after people notice the anomalies, the glow that doesn't fit, the orbit too tight to ignore, does the real suspicion start. Of course, not everyone buys this line of thought. Many experts argue that cometary physics is still flexible. Dust jets behave in unpredictable ways, brightness scales up and down, and weird examples don't require rewriting the rulebook. From that angle, building a stealth probe story just isn't necessary when one can stretch known science to cover the gaps. Still, the open question remains. How could we separate clever camouflage from raw nature? High-resolution spectra might reveal power sources beneath the coma. Direct imaging during close approach could expose structure under the haze. Conveniently, we may not need to wait long. When 3i Atlas swings by Mars in October, instruments on orbiters and rovers could capture the first sharp look. That encounter might finally answer whether this brightness is masking machinery or just wild cometary physics. But if what we see is neither clear dust nor simple ice, what exactly would that leave us with? The glow that doesn't match its size, the orbit that seems too precise, and the disguise that mimics a normal comet. All of it pushes 3i Atlas into strange, new territory. We've never tested an object like this before, and that's what makes it so hard to label with confidence. The next few months will matter. As it swings close to Mars and drifts deeper through our system, instruments will get their chance to probe the mystery. Whether it proves to be ice and dust or something engineered, the evidence is coming. Is it physics we missed, or did something build this? Drop your theory, wild or rational, in the comments, and join us as we chase the answers.